Section 6, in geometry, for our missing friends. Secants. So last section we learned about tangent lines or tangent segments. We reuse these words in mathematics, and there's actually a ratio in trigonometry called secant too, but you don't have to worry about that until pre-calc. So look forward to that your senior year. Secant lines. Secant lines are related to chords. What is a chord? That should be a strong hint. What is a chord in the circle?
Segment. It's a segment that goes from one side to another without going through a center point.
It's a segment that goes from one point to another on the circle. Now, if it goes through the center point, we call that chord a diameter. So chords just start and stop on the circle. A secant just goes through the circle. Doesn't start and stop. That's a secant line. It just goes through the circle. So line J, line K, those are secants. So we are going to learn things dealing with secants and measures of arcs. Maybe I should do just a little review. If we have a circle and I draw an angle, let's draw an angle like that. What do I call that kind of angle? Close. Central angle. And what's its measure like compared to the arc it intercepts out here? It's exactly
It's the same.
equal, the same. The central angle is exactly the same. So if I have a circle, and I have, there's my center, and I have an angle that is like this. We call that angle what kind of angle? Inscribed. And what is its measure compared to its intercepted arc? 1/2. All right. So now we're going to take some secant lines, and we are going to intersect them. Now, whether it is a secant or a chord doesn't really matter. But we're going to intersect it in a circle. Now, when we do that, we have created two pairs of intercepted arcs. So if I look at angle 1, the red ones are the two intercepted arcs that go along with angle 1. And if I look at angle 2, the blue ones are the intercepted arcs that go along with it. Now we know angle 2, we know both of these angles are the same. So when we talk about the measure of angle 2, it doesn't really matter which of those two vertical angles we're talking about. They're the same measure. Same thing with number 1 up there. So here's the formula. The measure of the angle that is formed is equal to 1/2 the sum of the intercepted arcs. So right here, the measure of angle 1 is going to be 1/2 the sum of the measure of arc AB plus arc DC. And angle 2 works the same way for AD and BC. So there's our fact for today. Number 1, at least, our fact for today. So taking that relationship, we'll let you see that relationship still. If I am going to solve for angle X right here, well, I know angle X is going to be 1/2 the sum of its intercepted arc, which are these two right here, 116 plus 47. You want to do that math for me? Please? You can use the calculator. What do you get for the measure of angle X? 81.5? Does Anna know what she's talking about on this one? Yes, 81.5. So right over here, I'm supposed to figure out the measure of angle X. Well, angle X, these are the two arcs, and they don't tell me anything about those two arcs. I know that angle X is supposed to be 1/2 the sum of those two arcs. Can you figure out any way that I could get the sum of those two arcs? Yeah, I know a full circle is 360, so if I subtract these two arcs from it, what is left, I guess I shouldn't call it X, what is left are going to be the sum of those two arcs. So I can find the sum by going 360, subtract the 75, and subtract the 55, and what's X on this one? 115? Part C. So they say X is one of the arcs. Well, no problem. Here's the other arc that goes with that angle 128. I know that 128 must equal 1/2 the sum of those two arcs, 154 plus X. I'm using the same formula. It doesn't matter where the unknown is. Now in this one, it's easiest to get rid of the 1/2 first. How do I get rid of the 1/2? Multiply by 2. So what's 2 times 128? 256 will equal 154 plus X. So now all we need to do is subtract 154 from that 256. 102. So there is that first property or theorem that we have, or fact that is true. Two intersecting chords or secants are going to form an angle whose measure is 1/2 the sum of their intersected arcs. So right over here, and I already drew this picture, so we don't need to talk about it again. So that's just comparing an intercepted arc and a central angle, an inscribed angle and a central angle. If a secant and a tangent intersect at the point of tangency. So here is a tangent. Point of tangency is A. And here's a secant that goes shooting through the circle. And if they intersect right there, now it doesn't matter whether they go along or not, then the measure of the angles formed, and there are two angles formed. Here's angle 2, here's angle 1, but both of them have the same relationship. It is just like the inscribed angle relationship. The measure of that angle is exactly 1/2 the intercepted arc. So it's the exact same relationship as this one, the inscribed angle. 1/2 the measure of that arc. So right down here, they want us to figure out the measure of arc JLK. JLK. Tell me the measure of arc JLK. Since that angle, 116, is half its intercepted arc, all I need to do is multiply by 2, and I get, which I hope is what I heard, 232 degrees. So out here they say the measure of angle RQS, the measure of this angle, that's what we're trying to find, I guess I'll call it X. If the measure of arc QTS coming around here happens to be 238. Well, I know that this angle is 1/2 its intercepted arc, which is that thing over there. So how am I going to figure it out? Yeah, take 360 minus 238 and I'll get this angle. What's 360 minus 238? 122. So all I have to do now is take 1/2 of 122, which is, how much? I have to measure my angle. So both of these relationships, let me review, whether I have intersecting chords or arcs, they're 1/2 of something. These intersecting secants or chords are 1/2 the sum of their intercepted arcs. And if I have a secant and a tangent, then it's just 1/2 the intercepted arc, just like an inscribed angle. Next theorem. We are going to take secants, or tangents eventually down here in the third picture, from a point outside. So these things are intersecting outside the circle. And when they intersect outside the circle, the measure of that angle, the measure of this angle A over here, is 1/2 again, but it's 1/2 the difference, and it's 1/2 the positive difference. You take the big measure minus the small measure. It's 1/2 the difference. All three of these diagrams are the same. Two secants, that's this one. That outside angle is 1/2 the difference. A secant and a tangent, same thing. It's 1/2 the difference. A tangent and a tangent, it's the same thing. It's 1/2 the difference. Now let me look at this one right here. Is there any way I could figure something out about the measure of this angle right here, that angle A? Let's say I called this arc BC X. What would be the measure of this arc if I called that arc BCX? Would not necessarily be 2x.
360 minus BCX?
360 minus that x. Because together, if you notice when I have two tangents, the intercepted arcs form a complete circle. So if one is x, the other is 360 minus x. Doesn't matter which one you really call x. All right, you might want to tuck that in the back of your mind. It might show up again at some point. Let's look here. Figure out the measure of angle S. So here we have an angle on the outside of a circle formed by a secant and a tangent. So we know that the measure of angle S equals 1/2 the difference, 179, minus 71. What's the answer? 54? Right over here, they give us that angle, and it's formed by a couple of tangents out here. So I know that angle, 68, must equal 1/2 the difference. So here's the big arc, 224, minus this small arc. They don't tell me anything. What can I call that small arc? X. So I'm going to get rid of the 1/2. I'm going to multiply it by 2. Oh, that's there. I'm going to multiply it by 2. What's 2 times 68? 136 equals 224 minus x. So I'm going to add x and then subtract that 136. What's the measure of that missing arc? 88. So today's work really comes down to those little formulas that we had. Those are the three properties that we start with. The diagram shows the path of a light ray as it hits a drop of water. So here's what happened. Light enters this drop of water from the left. It refracts, it bends, it refracts. And we know exactly how much it fracts depending on the color of light right here, and it reflects a different amount. And then it hits the back of that water droplet, and it reflects, it bounces off. And it comes right down here. And then when it comes out of that water droplet, it refracts again. It bends again. And here's the light ray that exits from this light ray that enters. And this water droplet and its refraction, reflection, refraction as it goes in and out is what forms the rainbow. Because every color, if you look at that cool little electromagnetic spectrum right up there, and there's a tiny little part of that that's called the visible spectrum, and you know about the rainbow or the spectrum, red, orange, yellow. What's the order of those colors? Red, orange, yellow, somewhere in your elementary school science classes. Red, orange, yellow, green, blue, indigo, violet. Remember memorizing this guy named Roy G. Biv? Did any of you guys? Yeah, right. Roy G. Biv? Yeah. Oh, that's a little mnemonic device to remember red, orange, yellow, green, blue, indigo, violet. What happens is the different colors are from different wavelengths. They're also different frequencies. And they bend a different amount, slightly. And so that's why white light, as you look at the white light around you, that's really made up of what? All the colors. And when we combine them all, it looks white to our eyes. That seems a little funny, but that's what happens. We see white when we combine all those colors together. And each one of those colors that is in that white light, if it bends just a little bit, that's what separates it. Right over here, it separates it. And so as you look at it, you see the red, the orange, the yellow, the green, the blue, the indigo, the violet, and it always is in a specific order. The only time you see a rainbow is when the sun is behind you in some way. Now it can be off to the side a little bit because it is shining in front of you on some moisture, water droplets in the air, and that's where it's refracting and reflecting and refracting and coming back to hit your eye. And it's in this process that those colors get separated. Well, the physics lesson. The ray is bent or refracted at points A. It's not refracted at B. It's reflected right there. And then C, it's refracted again. The measure of arc AC is 128. So 128 is the one right in here, AC. And arc XBY, this one right over here, happens to be 84. What is the measure of angle D right out there? If I took the original entering and exiting rays and drew them back, then they would intersect at some point right back there. Measure of angle D, you help me out. 1/2. Anna is not allowed to answer this question. What's the measure of angle D? Thank you very much for your participation. Without you this morning, I wouldn't have gotten many answers. But now we're going to have some others help us. 22? 22? Is that what we're getting?
Yeah.
22 degrees. Beautiful. Here is the summary of what we know about angles. On a circle, an inscribed angle or an angle formed by a secant and a tangent both measure 1/2 that intercepted arc. They're calling the arc X, and later they'll have arc X and Y. If I intersect two secants inside a circle, so inside a circle is what's going on, then we have 1/2 the sum of those intercepted arcs. And if I intersect outside the circle, then those angles, all the same relationship, they are 1/2 the difference. So there's the summary of all, except the central angle, which we know equals. Those are the summary of all those angles we have had so far. So I believe you are now ready to do a worksheet.